Hello and welcome to WB and Video Maths here. And I'm back with another your daily dose of integration question. And we have this question here, sin x by 1 plus sin x dx. As you can see, it's a trigonometric based integration question. When I look at this, I can see a cos square x. I'll tell you why I see that. If if we did this, let's say 1 plus sin x, and if in case I multiplied it by 1 minus sin x, and divided by 1 minus sin x, I would have sin x multiplied by 1 minus sin x divided by 1 minus sin square x. And this, if you can recollect, it is cos square x. Now it's kind of looking decent, I would say. Not in all cases. You cannot always make the coefficient or the denominator in such of terms that might be useful to you. I mean, this is like pretty useful. I mean, I can get a sine by cos, which is a tan, and tan we can work with tan, something we can do. I'm not saying like we have a concrete plan, but we can do something instead of like how it was. Going back to what we have, sin x multiplied by 1 minus sin x divided by cos square x dx, which can be written as sin x by cos square x. If I multiply the sin x in between, like into the square brackets, I get this dx minus integration of sin square x divided by cos square x dx. Now this is two integration parts, if you can see. This is one integration. I'm gonna call it I1. This is my I2, and I'm gonna solve them separately so as to find get to a decent solution. So, first what we have here is by cos square x dx, which can be written as sin x by cos x and 1 by cos x. Why did I do this? Because this looks like a tan to me, and this looks like a this is whatever is rest, which is a secant and dx. And you would see why like it is important to do this. Not important, it's just a basic idea. And integration of this is secant x plus c1, let's say some constant c1. That is our I1 part. I1 is equals to this. Coming to our I2 part, integration of sin square x by cos square x dx equals to, this is nothing but sin by cos, which is tan, and there's a square, so tan square x dx. And it still doesn't look, I mean, we don't have a straight out formula for this. So what I'm going to do is we have this identity, secant square x minus tan square x, which is equals to 1. And from this, tan square x can be written as secant square x minus 1, which I'm going to substitute here. Secant square x minus 1 dx. This is going to be integration of secant square x dx minus 1 dx. And we know the integration of secant square x is tan x minus 1 is x plus c2. And this is the integration, like the part for I2. We have this equation, sin x by 1 plus sin x dx. Now putting everything back, we have I1 plus I2, which is secant x plus tan x minus x plus some whole constant c. And there we have the solution. And I hope you enjoyed this question. Thank you for watching. I'll see you in the next one.